Okay, let's start out this second video on profile and take a minute, make sure that we have a mental picture at least of what the distinction is between these two symbols. The profile of a line and profile of a surface. If you remember when we talked about form controls, we talked about straightness of a surface, and we sort of compared it to flatness of a surface, where we can look at any linear element on a surface and measure those individually for straightness, or we can define a total flatness by comparing it to a plane instead of a line. And if we have a part that is, say, dipped like this, that we can look at the linear elements individually, and even though the surface isn't flat, the individual linear elements are or can be straight, and we can measure that separately. The same thing sort of applies here with profile, is that we can look at the entire surface in its entirety, or we can look at that surface as an infinite series of lines. Okay, so if we looked at this part and we imagine that this top surface, even though it's rolling, it's flat. It's kind of like a road that just has some humps in it. So if I were to take this pencil or this marker and roll it along here, it would sit somewhere on this surface and stay in contact. There's an example of where we would use the profile of a surface, where we can define a fairly uniform surface that simply bends. I guess another example would be like taking a sheet of paper and flexing it. It would stay flat or straight in one direction, curved in the opposite direction. If this surface, on the other hand, instead of being a straight line here, had a bit of a crown to it, like this. In other words, it's curved this way and it's also curved this way. That's an instance where we would use profile of a line, because instead of being able to measure across this entire surface with a plane, we would have to measure each one of these individual lines as it comes along. Now, where would you see a feature like that? Very often gear teeth they're curved in one direction, but very often they're also curved in another direction. So they have sort of a barrel shape or a barrel nature to them. They're curved this way and curved that way. So when you have complex curvatures like that, we often end up using profile of a line. So that takes a little bit of thinking and a little bit of visualizing to realize that there is a difference between if this surface is what we call a ruled surface. In other words, a ruled surface is curved, but there are somewhere on that surface there will be a straight line. In other words, you could lay a stick on it and it would sit flat. In the case of this surface, if it were crowned this way and rolling this way, there would be no location on that surface that would be what we call a ruled surface, or be able to lay a straight stick on it. Okay, what I wanted to do also here is the standard does allow you to define that tolerance zone a little bit more clearly than using the unequally disposed symbol. And I think in the few instances where I've ever encountered this, I think it'd be a good idea to not use this, but to do the alternate practice that they're showing there. So if you look in figure 8-4B, you'll see that we have this symbol. I think there's a 0 in there instead. And that is the full GD&T way of doing it, using just the feature control frame. As an alternate practice, they show over here that you can put the feature control frame on a leader and skip using you avoid using this and that. You simply say, I want all my tolerance zone to be 0.8. So basically you are drawing the tolerance zone on the part. You're defining with a dimension, usually a basic dimension, that tolerance zone, or you're using the feature control frame without the U modifier. Again, I think that's a lot more clear, especially if you're going to do something like in figure 8-4D, where you've got a little bit of the tolerance, 0.2 of the tolerance on the plus side, 0.6 on the minus side. I think the use of this this line, that line I think is called a chain line in drafting. It's one of the few times they actually use a chain line. But it defines a zone that doesn't really exist there, but it's a definition or basically a drawing of the tolerance zone instead of just defining it with the feature control frame. So again, I kind of like this practice. What I do want to make clear to you here is that you do this or you do this. You don't do both of them. You know, you don't use one instance for one tolerance zone and then go to something else again. You stick with one approach. And again, if I had to do that, I would, I think, use this approach. To me, it's a lot more clear. Okay, I do want you to take some time here. I'm not going to say too much about it, but I want you to look at below this figure 8-4. You'll see the means this sort of a defining series of sketches that shows you what the tolerance zone looks like, what the datum has, how the datum relates to the tolerance zone, and it also shows you something that I think you may not think about and is a very critical aspect to this, is that as always with tolerance zones, once you've defined one, unless you define another tolerance zone for some other purpose, sort of get rid of the isometric portion of this, unless you define the tolerance zone for some other purpose. So we've got, I'm going to go back to the bilateral tolerance zone. If that's the only tolerance zone you have, that tolerance zone establishes the controls for all aspects of that feature. It controls, obviously, the profile of it. It also defines the cylindricity of these surfaces. So if that surface actually looked like that and fit within that tolerance zone, that would be close enough. It takes care of the size and the form and the position. In other words, this surface can be all the way up here as long as it doesn't violate that boundary, or all the way down there, or it can actually do that. As long as it fits within the tolerance zone that you've defined and you don't have anything else controlling anything else, that tolerance zone does it all. So you have to be very, very careful when you use a tolerance zone like this, that, as I said, it's an omnibus tolerance zone. It controls everything. It will control the size of these features, the form of these features, the orientation of these features. In other words, this whole surface could be tipped like that within that tolerance zone. So it controls the orientation. It is controlling everything. And that is a deadly scenario if you're not aware of it. You can end up with some truly ghastly features that fit within the tolerance zone and would have to be accepted. So again, I always emphasize that if you're going to use a powerful tool like a profile, you really think about what it is controlling, and that's what these sketches are intended to point out to you, is that they show this, raggedy surface, and that raggedy surface is acceptable in terms of what's on this drawing. It's simply this tolerance zone, And if it's that wide, anything that fits within that tolerance zone is acceptable. So keep that in mind. I do want you to, as we go along here, always look at these means this portion. This is one reason I teach out of the standard and not out of the many interpretive books that you can buy, is that I think the standard does as good a job as anybody defining the gotchas here. And this is truly a gotcha. The fact that as simple as it makes, as simple as it allows you to define that tolerance zone, measuring it and being aware of all the things that can go wrong and still fit in that tolerance zone, that's not as simple. So again, be super careful with this. The tendency more and more, as I said in the previous video, is to try to use profile for all these things. And so I don't need a form control, I don't need a positional control, I don't need an orientation control, I'll just do it with profile. But you'll learn pretty quickly that those are separate controls for a reason, and the reason is that sometimes you want something that's really nice and flat, and it can be tipped a little bit, that's okay. So it can have a larger orientation control, or orientation tolerance, than the form tolerance. So we separate those controls for that very reason, and the lazy engineer will, say, I'll just use this profile tolerance. And of course what he'll do is he'll make it extremely tight. So not only is the form and the orientation and all the things that that tolerance zone is controlling are tightened up, and that's an expensive proposition usually. Okay, so let's chew on that a little bit. At this point, I think you should have access to the test on Canvas. I'm going to leave that test up for the rest of this week. It won't be due till Monday. I don't want any sense of urgency to this. I want you to take your time, take the test. Obviously, there's a very unique situation here where we're can't really review in a proper way. All you can do is review your notes, the handouts, and the videos. So again, I'm not going to be too stringent about this test here. I just want you to, I want to get a feel for whether this is really sinking in the geometric aspects of it. So anyway, take that test. This is my first test on Canvas. I don't know that I've ever tried it before. I know I haven't. And as I said in an email, it's a little cumbersome to work with. It has a lot of controls, and I don't know that I've touched all the controls in the right fashion. So if you have any problems, obviously contact me. But again, I would like to have that test done this week or this weekend, so that I can get that initial grade. We are nominally, I think, at our halfway point. Hard to believe, but we're moving right along. Once we get through profile here in the next 3 or 4 videos, we're going to really jump into probably the most challenging control, which is position. It's far and away the most complex, far and away the most commonly used, and it has a tremendous range of uses that we're going to try to at least touch on some of the ones that aren't super complex. So anyway, think about this. In the next day or two, I'll put another couple of videos up here. We'll talk about, if you want to study ahead, you can study figure 8.8-5 and 8-6. We'll talk about some of the complicating factors of putting tolerance zones all the way around things, or where tolerance zones can change from one aspect of a surface to the next. Again, it can get very complex, and even though the tool is there, I don't know that I've ever seen in many years it actually used in that way. So as much as I want you to know it, I wouldn't worry about it. If you ever encounter it, you can always go back to the standard.